This is Algebra Review Day 3. And the topic is multiplying polynomials. So at this point, you guys know how to multiply a binomial times a binomial. Right? So for example, if I was going to multiply 2x plus 3 times x minus 8. Okay? Binomial times a binomial, two terms in each of those. So there's actually a couple strategies that we could use here. We could do what's called the table method or the box method, whatever name you know it as. And the idea behind the table method is it just gives us a nice way to organize what we're doing when we're multiplying. Because essentially what happens is I have to take everything that's in this set of parentheses and multiply it times everything in this set of parentheses. And it's easy to, get confused and miss something. So we can use the table method just to help us get organized. So I'm going to set up this box situation here. I'm going to label with my binomials. It doesn't matter kind of which one you put on which side. So I'm going to put my 2x plus 3 down the left, and then I'm going to do x and negative 8 for my x minus 8 on the top. And then I'm going to go through and in the boxes, write the product of what I get when I multiply. So here I'm going to multiply 2x times x, which is going to give me 2x squared. And then I'm going to do 2x times negative 8, which is negative 16x. And then I'm going to do 3 times the x down here and get 3x. And then 3 times negative 8, which is negative 24. There we go. Okay, so what we have there, if we wanted to write it all out again, I've got 2x squared, right, minus 16x plus 3x minus 24. We know at this point that we would combine our like terms together in the middle here. So we would end up with 2x squared minus 13x minus 24. And there's our product. Okay, going back to, again, this idea of multiplying everything in one set of parentheses times everything in the other set of parentheses, what we're really doing when we're multiplying like this, right, is we are distributing. So you may prefer to do it this way with sort of a double distribute, or you may be aware of the acronym FOIL. Right? FOIL, which stands for first, outside, inside, last. And yeah, it just gives us a way to kind of keep organized when we're multiplying. So let's do this out again using this other method, and we can see how we're going to end up in the same spot. Okay, so if I was taking a distribution approach or using FOIL, right, and we'll do it separately. Again, what I'm really doing is I'm taking everything inside this first set of parentheses and then multiplying it through times everything in the second set of parentheses. So I'm going to take this 2x, right, and then I have to multiply it times the x minus 8. And then I'm going to take the positive 3 and multiply that times the x minus 8. So when I simplify that and I distribute through here, so 2x squared minus 16x, and then over here I would have plus 3x minus 24. All right, I'm going to end up in exactly the same place I did a second ago. 2x squared minus 13x minus 24. Okay. Again, you may know FOIL 2, which again just stands for first, outside, inside, last. So you multiply the 2x times the x for the first. The outside would be the negative 8 and the 2x. The inside would be the 3 and the x. And then the 3 times the negative 8. Just got lots of different ways to do a 2 by 2. And that's review from before. What we're going to do now, though, is extend this, right, to polynomials with more than 2 terms. What if I wanted to throw a trinomial in there? So the good news is, really what we want to end up with here, is this box method is great because it really works well for any number of terms times any number of terms, especially when we get up into the 3 by 3, which we're going to do in a second. Again, it's the same exact thing as distributing. It just gives us a way to organize it. So we'll do a couple of problems both ways, and you can see kind of which one you prefer. But I would definitely keep my eye on this box method. It does provide some nice organization as we go through here. Okay, so let's take a look at multiplying a binomial, right? So two terms, and a trinomial, which is 3. Right? So what if I want to do 2 terms times 3 terms? Okay, so here's my first example. I want to multiply x plus 3 times x squared minus 4x plus 4. 2 terms times 3 terms. Okay, again, we'll do it both ways to show you. Again, I'm going to start with the table method. So same concept as when we did it with a 2 by 2, except now I'm doing a 2 by 3, right? So when I set up my table, I'm going to make it a little longer so that I've got 3 and 2, and they are not evenly spaced at all. Okay, there we go. 2 by 3. All right, so down the side, I'm going to put my binomial, x and 3, and then across the top, x squared, negative 4x, watch out for those signs, and a 4. Okay, now I'm going to go through and figure out my product and put it in the squares. So x times x squared, x to the third. X times negative 4x squared, and then positive 4x. In the bottom row of the table, 3 times x squared is 3x squared, 3 times negative 4x is negative 12x, and then 3 times 4 is 12. Okay, so again, if I just list out here my results from my table, 4x squared plus 4x, and then I have 3x squared minus 12x plus 12, right, now I can start looking for those like terms that I can put together. All right, so I've got the negative 4x squared can go with the 3x squared. I've got the positive 4x, oopsies, that can go with the negative 12x. So when we put that all together, I'm going to have x to the third, negative 4x squared, and positive 3x squared is going to leave me with a negative x squared. Positive 4x and negative 12x is negative 8x. And then I've got my positive 12 to tack on the end. And there's my product. Now, one of the reasons why I really like this table method is that actually you can kind of skip this whole step of writing it out. Because if you check out what's happening in the table, right, notice that the like terms, they're actually very close to each other, right? Like they're kitty corner. Here's the 3x squared and the negative 4x squared, and then negative 12x and 4x can go together. And then the x cubed and the 12 don't go with anybody, so they're on the end. So it's actually pretty easy to tell from the table which like terms go together, which is another reason why I really like doing it this way. Again, if you wanted to try it with distributing, you can do that. You're still going to end up in the same spot. So again, what we're really doing is we've got to take each term from the binomial, multiply it times everything in the trinomial. So I've got to take the x and then multiply it by x squared minus 4x plus 4. And then I'm going to take the 3 from the binomial and multiply that times x squared minus 4x plus 4. Okay, and then if we distribute it through, x cubed minus 4x squared plus 4x, and then 3x squared minus 12x plus 12. Right, you can see we got exactly the same thing that we got up here from the table. Again, I have to go through and look for my like terms, right? 4x squared and the positive 3x squared, and the 4x and the negative 12x. And we put them all together. X cubed minus x squared minus 8x plus 12. Okay, so again, get exactly the same thing. Again, I do think this table method is easier, though. That's the way I prefer to do it. So most of the time, you're going to see me do that. So I would encourage you to give that a try and kind of get the hang of it. It does make it easier. Okay, so that was 2 terms times 3 terms. Okay, let's take it up to the next level. One more. How about a 3 term times a 3 term? All right, so now I want to do x squared plus 3x plus 1. And I'm going to multiply that by x squared minus 5x plus 2. Okay, so I see the 3 by 3, and I'm jumping right to the table. Oh boy. Can't draw straight lines. There we go. Okay, so I got 3 and 3. Alright, I'm going to label my trinomials here. Again, doesn't matter which one you put on which side. X squared, 3x and 1. Across the top, x squared, negative 5x, and a 2. Okay, and then here I go with my multiplying. So, x squared times x squared, x to the 4th. X squared times negative 5x, negative 5x cubed. X squared times 2, 2x squared. Next row, 3x times x squared is 3x to the 3rd. 3x times negative 5x, negative 15x squared. 3x times 2, 6x. And then my bottom row, multiply everything by 1, x squared, negative 5x, and 2. Okay, so I'm going to look at my table. I'm not even going to write it all out because, again, if you look at this table, right, it's pretty easy to spot. Here's some x cubes that are going to go together. Here's a bunch of x squareds that are going to go together. The x terms are going to go together. And then I've got these guys on the outskirts there. So yeah, it does really make this, even when you're doing a 3 by 3, pretty painless. Okay, so we've got x to the 4th. All right, then I got 3x cubed combined with negative 5x cubed, so that's negative 2x cubed. Positive 1x squared, negative 15x squared would be negative 14x squared. All right, add that to 2, so I'm going to get negative 12x squared. Negative 5x plus 6x, positive x, and finally finishing with positive 2. Okay, and if you're going to try to do that with distributing, and you can do it, but you're doing x squared times the x squared minus 5x plus 2, right? And then you would have to do 3x, x squared minus 5x plus 2, and then plus 1 times x squared minus 5x plus 2. You know, you have to go through all that, multiply everything all together, combine your like terms. Yeah, you can totally do it. You get here. I do think it's a little messier this way and harder to find those like terms. So, and if you're trying these problems and not doing the table and you find that you are not getting them correct, highly encourage you to try the table. It really does make this a little bit easier. Okay, we have one more thing we're going to do with our multiplying of polynomials. We're going to use them for something. So we're going to look at verifying some identities. Okay, so an identity in math, it's a mathematical expression that is always true. A mathematical expression that is always true. So, for an example, I've been doing some stuff with factoring. So let's just say I had x squared minus a squared there, where x and a could be any numbers, right? Just using variables. We know from what we know about factoring that we can use our difference of perfect squares there, that would factor into x minus a times x plus a. Right, that's difference of perfect squares. So we already know that, and that's actually an example of what's called an identity, because that's something that's always true, right? Whether it's x squared minus 4 or 25 minus y squared, it's always going to follow this pattern at the end. Okay, so there's our identity. Okay, so let's take a look at another identity, one that we're going to want to show is true. Okay, so verify the identity. Verify that V-E-R-I, root word there is root word for truth, right? So it's something that we want to prove is true. Okay, so here's my identity that a plus b times a squared minus ab plus b squared is equal to a to the third plus b to the third. Okay, so it's my job to verify that this thing equals this thing. Okay, when we're doing something like this, what I'm going to kind of do is just draw this wall down the middle here. And basically, it's my job to show that these two sides are equal to each other. So, I'm not quite sure what to do with this. I do, however, know how to multiply 2 terms times 3 terms, right, based on what we were just doing. So I got to go through and do that, and if I do it correctly, it should come out to be this at the end. That's our job, to show that that's true. Okay, so 2 terms times 3 terms. I'm going to go to my box method here. Make a 2 by 3. So a and b, a squared, oopsies, minus ab, and b squared. Okay, I'm going to multiply. So a times a squared is a to the third. A times negative ab, negative a squared b. And then a times b squared is ab squared. In my bottom row, b times a squared is ba squared. B times negative ab squared. B times b squared is b to the third. Okay, so I've got my eye on, where those like terms would be. Since this is actually, an example of a proof, actually, it's an algebraic proof, I am going to write this out. AB squared, just writing out my product here so we can look at our like terms a little closer. B cubed. Right, because if you haven't spotted it yet, there are some like terms in here, right? So check this out. This negative a squared b, and right here I have ba squared, but it's multiplying, so the order doesn't matter, right? So this negative a squared b and this positive ba squared, right, those are actually the same thing. Same. Right, and not only that, but they're actually going to cancel themselves out because one's a negative and one's a positive. Okay, so those are gone. And then right here, I've got positive ab squared, right, and then I've got negative ab squared. So those are also going to go. Okay, so as part of my proof, I say, hey, that cancels with that cancels with that, and I'm left with a cubed plus b cubed, right, which is what I was trying to show. Okay, so I verified my identity. I've got the work to show when I multiply this out. Okay, that's the idea behind verifying those mathematical identities. Okay, I've got one last problem for you to practice. So here's one you can try. We're just going to multiply here. Okay, so m squared minus 5m minus 6 squared. Okay, m squared minus 5m minus 6 quantity squared. Okay, so the first thing you're going to do is be real careful. Right, remember, I cannot distribute an exponent to something like this. No, very bad. Right? Got to multiply this all out. This means I got to do m squared minus 5m minus 6 times another m squared minus 5m minus 6. So, up to you. You can distribute, or I would recommend you try this with the box. Take a second. You can pause the video. Try it on your own. See if you can come up with the right answer. Okay. So here I go with my 3 by 3 box. There we go. Alright, m squared minus 5m minus 6, m squared minus 5m minus 6. Okay, m to the fourth, negative 5m to the third, negative 6m squared. Then it would be negative 5m to the third, positive 25m squared, and a positive 30m. And my last row, negative 6m squared, positive 30m, and a positive 36. Okay, and then again, the nice thing about the box is I can find my like terms real easy. They're kitty corner to each other. So m to the fourth doesn't go with anything. Negative 5m to the third and another negative 5m to the third. Negative 10m to the third. Negative 6m squared plus 25m squared plus negative 6m squared. All right, so that's going to leave me with positive 13. So positive 13m squared. 30m plus 30m is 60m. And then finally, I've got my positive 36 at the end. Okay, so a trinomial times a trinomial. Okay, that's the end of Algebra Review Day 3.